Hello and welcome to another episode of Curiosity Labs Between Two Nerds, where each week we get a small human being to sit in between us and have a little chat about science. If you are watching us on YouTube, I hope you're enjoying this, but you need your eyeballs for something else. You can find us on all the major podcast channels. And if you're listening to us on the podcast and you'd like to know what we look like, don't know why you would like that, then check us out on YouTube, Between Two Nerds. If you like, please hit that subscribe button, hit that little bell so we can tell you when there's new content up, and leave a comment with any kind of feedback. We're thoroughly enjoying that feedback so far. Now, this week, we have a most excellent tiny human with us. We have...
I'm Athena, and I'm 11 years old.
Hey, Athena.
Hi.
How are you?
Good, thanks. How are you?
I'm good, thank you. How polite.
So
no
lovely.
one ever asks me.
No one cares.
All right, and you know the nerds are Mo.
And I'm Eugene.
Cool. All right, Athena, what would you like to talk about?
Time travel.
Cool.
Easy.
Very cool. Yeah, what about it?
So, would time travel actually be possible?
Yep, I've done it.
Wait, what?
Yeah, I have. And you have.
You're doing it right now.
We're all traveling through time, just all at the same rate and a second at a time. Yep, there you go. Next question.
So,
Time travel, done.
Yeah, so
I think that was
so
a
you asked,
facetious answer.
is time travel possible? Okay. It's a good time to ask these questions. I just finished an amazing book on time, which is amazing, but confused me probably even more.
Is that the order of time?
Oh my God, have you started it?
No.
Oh, it's brilliant.
I've got it.
Finished it. Okay. So time travel is, to be honest, okay, it depends on what you mean. Okay, so we're all traveling into the future, right?
Yeah.
That's obviously not what you're going for. But here's the weird thing about that. So there's very non-theoretical science, right? That has been backed up with experiments and observations that shows that we can travel into that future at different rates. And it's all about Einstein's theory of relativity. Okay, so there's both. So there's a special relativity, there's two theories of relativity, which says that time, although we think that time moves at the same rate for everyone. So that means 1 second for you is the same as 1 second for me, and the same as 1 second for Eugene, and even 1 second for the astronauts in the space station. They're all the same, right? But actually, depending on how fast you're moving, right, time can slow down. So so I'm sat here, if you got up right now and you started just running across this recording studio, right? Time for you while you're moving will be, your 1 second would be slower than my 1 second. So you would be aging slower than me.
okay.
Right?
So long
time
life,
can change.
just keep moving.
Yeah. Okay. Yeah, so time moves slowly. So actually, so one of the things, let me try to make sure I have the right math on this. So the closer you're moving to the speed of light, the slower time moves for you. Okay? So let's say, right now it's 2020.
Yeah.
Happy New Year. Right? So you got into a rocket, right, that can move at 99.5%, I had the math, but let's say 99.5% the speed of light. Okay?
Really quick.
Yeah, very, very fast. And you got into that rocket and you went on a 5-year trip, just wherever, it doesn't matter where, right? You're just traveling at that speed for 5 years. And when you came back, so right now you're 11, right?
Yeah.
And it's 2020. So when you came back to Earth after 5 years, you'd be 16 years old.
Okay.
But the year on Earth would be 20, I think it's 23.
Have a punt.
Another
Someone
30
will
years,
correct
something like
us.
2050.
Oh, wow.
Or was it 50 years extra? Yeah, something like that. Right? So that's how. So they said there, you and the Earth has traveled into the future at different rates.
Ah.
Okay?
Okay.
Right, so that's what relativity says. The faster you're moving, the slower time moves for you. Okay? Now, one thing about this book. Okay, so we have the future. What about the present, right? Now, one of the things is there is no present for the universe.
There's no moment in time.
There's no one moment you can say, right now, this is the present of the universe. Because the present, so everything in the universe is happening at different time scales, depending on how fast things are moving, how much gravity there is close to it. These things, how much mass there is. If there's mass, then there's gravity. So all of that means that the clocks all around the universe, let's say throughout the universe, there are clocks, right? All the clocks are moving at different rates. So to say now means nothing. There's no present.
Okay.
Okay. There's a present, like local present.
Yeah.
So right now we can all say we're in the same moment because we're pretty close to each other. But let's say you go a little bit further away now, even then, like if you're looking at something happening, like let's say out that window, there's a bird flying, right? Let's just say there's a bird flying. Now the light that left that bird and traveled to us it's moving very quickly, but it still took some amount of time. So what you're actually seeing is that bird in a few microseconds in the past. And you can take this for the stars. Now, with the stars, let's say the closest star to us is Proxima Centauri, right?
Yep.
It's not Alpha Centauri, Proxima, because it's close.
Makes sense.
Yeah. So it's 4.7 light years away. That means when we look at that star, we're not seeing that star now. We're seeing that star 4.7 years in the past.
Okay.
Does that make sense? So what you're seeing is the light. So if you think of light as a thing, right, imagine light, pieces of light.
Photons.
So if we do this on a tiny scale, what you're looking at my face right now.
Yeah.
Sorry about that. But you are seeing the light that is coming from my face to your eyeball. So the piece of light that's leaving my face right now will travel and hit your eyeball.
Yeah.
So, but when it hits your eyeball, what you're seeing is my face at the moment that piece of light left my face. Now, if you scale that distance to something where it takes that piece of light 4.7 years to hit your eyeball, then what you're seeing is 4.7 years ago. So if 3 years ago, in a moment, so 3 years ago in our moment, that star disappeared, you would still be looking at it.
Yeah.
Because you'd be seeing that light. You wouldn't know that star disappeared until that light stopped and that last piece of light hits your eyeball and there's no light. That's going to take 4.7 years.
Yeah.
So you might be looking at something that didn't exist.
Same thing, like even with our sun. So the light from the sun takes 8.5 minutes to reach us. So if something happened to the sun and it just vanished, right? We wouldn't know until 8.5 minutes later from that instant that it actually disappeared.
My favorite, so, my son Indiana, he's 8 years old, loves Harry Potter, spoke to you about Harry Potter for ages.
Yeah,
but
this
blew his mind. So he now walks around thinking that everything he's looking at is that.
Yeah, so you're seeing the past.
Seeing in the past. It's impossible to see.
So there is
the present.
But
if the UAE are doing it, but we send things to Mars. And it's very expensive to send stuff, particularly when you want it to land on a planet.
Yeah.
And there's a moment where, let's say, that probe or that Mars rover is coming down and landing.
Yeah.
And that's super scary if you're working for the space agency here or for NASA or whoever's in control of that. There's a lot of money and a lot of pressure. Now, that's generally radio waves, which are even slower than light.
Yeah.
Light.
Is it light?
Speed of light.
Oh, fine, speed of light.
Yeah, because the radio waves are light, so it's always, that's the top speed.
Right, so that's traveling, but that takes, I think, 5 minutes, 6 minutes to get from Mars to us.
Yeah.
So they've got lots, and there's things they can do to control if something goes wrong. But you see them in their space center, super, super stressed and super, super nervous about whether this thing's going to land. And what they're watching and they're waiting for the moment, did it work, didn't it work, has already happened. So it happened 5 minutes ago. So if this thing crashed on landing, they're sitting there waiting. There's nothing they can do about it.
It's kind of
so
like
you're watching the past happen.
It's kind of like when you have a long distance phone call and it's a little bit out of sync. Having
delay.
that conversation is so annoying because all these signals, again, traveling and electric signals take time to reach, right? Yeah. So if you're ever talking to someone, let's say from here in America, sometimes, right, you have a delay in the signal.
Yeah.
Right? So it makes that conversation very, very hard to
Difficult to watch.
Yeah. Okay.
You see it on the news.
You have to talk and you have to wait.
Yeah.
For them to reach it, hear it, and then say something, and then so it gets really strange to have that conversation. But so we're all moving in the future. We can do it at different rates, right? There's no such thing as the present. But really, what we want to do with time travel here is to go to the past, right?
Where which way would you go to and we'll talk about it, but if through some magic, I could click my fingers and say, right, you can go, presumably on Earth, backwards or forwards, where would you go?
Maybe both? Can I do
No,
both?
you've only got one.
You got to choose one.
Maybe the future.
You'd go to the future.
Yeah.
How far forwards do you think you'd go?
Like 1,000 years?
Yeah, that'd be interesting. I've been having this debate in my head because I always think this. It's like I'd go back and see the dinosaurs, or I'd go back and hopefully not get eaten. But I'm reading the book about the ancient civilizations and the theory that there might have been human civilization way earlier. And it's like, well, I'd go there just to find out if it was true. So I think I'd go backwards. I think. I don't want to see me old.
So it's really going into the past, which is a problem. So that was special relativity, right?
Yeah.
Now Einstein, 10 years after he came up with special relativity, which was a huge deal, came up with general relativity, which explains what gravity is, right? It's a bending of space and time.
Yeah.
So, because it's curved, there are paths you can take in traveling through space-time where you arrive before you left. It's possible, right? So you can sort of go into the past now, but the problem is because it's not happening, right? Scientists there's nothing that definitively says that it's not, I'm not sure, actually I should say that. There's nothing that definitively says that it's impossible yet.
Yeah.
The theory that we're using, general relativity, right, says that it doesn't say it's not possible. And there are possible, like when you try to solve these equations, you can see ways where you could arrive before you left, let's say, so in the past.
Yeah.
But most scientists think that there's probably something there that disallows it, that we don't know. Now, the problem with this is general relativity, which I love. Like, it's one of my favorite theories, if you have one, right? I love general because it's just so incredible at explaining everything.
Yeah.
Right? At explaining what gravity is and even the demonstration of it with the trampoline. I love it. It's my favorite theory. And but it's still not a complete theory, which always annoys me. I was like, oh, come on. It's so good, though.
You do it.
Yeah, right. Okay. The problem is that gravity, this theory, works in almost all domains, almost all cases, except for in the very, very, very tiny cases. So in things like a black hole and stuff, this theory that we would use to even predict black holes just breaks down. So we need a theory of gravity on a very small scale called the quantum scale. So to get a full picture of gravity, to actually be able to find out whether this is even possible, we don't have the full story yet for that one theory, for the theory of space-time, basically, right? For gravity. So until we get a theory of quantum gravity, right, we won't really be able to answer that. Famous scientists like Hawking and stuff, they've tried to find out there must be something that says that it is not possible to time travel backwards. Otherwise, things would do it, possibly, right? So they were trying to figure out what that is, what's preventing us from moving into the past, right? And they haven't found anything yet.
But I think Stephen Hawking's he had a party for the time travelers. So he held a dinner party for time travelers,
And no one turned
and he
up?
didn't send the invites until after the event, and no one turned up. Not surprisingly, but I suppose because you can get into some crazy science, but there's the human common sense way of thinking about it. If time travel backwards was possible, surely we would know, because someone from the future
Would come back and
have
tell
come
us.
back,
Yeah.
and we would know about it. And that, based on that kind of logic,
Yeah.
you'll find loads of stuff on YouTube of people sitting there saying, "Well, I figured it out, and this guy is from the future."
But one of the things, right? Okay. It's a case of like, what if we could travel into the time travel is possible, but you need to make something that allows you to time travel. It's like, okay, so when you invent the first telephone, it's great, but unless you had another telephone to call, you wouldn't know if it worked or not, right?
Yeah.
So you need the equivalent. You need a time travel machine now. So maybe, right, so what you need for time travel to happen is to have something that could be used for time travel now, so that people from the future can use it. So when they switched on the Large Hadron Collider, have you heard of this? It's a big giant electromagnet and superconducting superconductor, whatever, right? This hadron, so it's a particle accelerator.
It's a massive ring in the ground.
In the ground underneath Switzerland and Italy. And they thought when they switched this on, maybe this could be the telephone for people from the future to time travel back to us. I mean, not serious people thought this, but there was a theory. So, I mean, I don't know how it would be possible, right? So to answer your question though, there's nothing that, as yet, that disproves that it's possible to time travel into the past, right?
Yeah.
Future is easier.
Yeah.
Future is much easier.
1 second at a time, I can do that.
Yeah.
But do you have any ideas how they might do it? Like a time travel?
I'm not sure.
It's a wild guess. Come on, these are all wild guesses anyway.
Like black holes or something?
Okay, yeah. See, yeah. So that's possible, a black hole. Or not a black hole, because we don't know what happens in a black hole. You could fall in and
fly
nothing.
into the future.
Yeah. You could, right? But so it would be a wormhole.
Yeah.
Now, what a wormhole is, okay, is that it is a tunnel between two regions of space-time. So it's like going so here's A and B, right? Now you could travel through A and B, but you're going to be in all these different places in between, right? But if you have a wormhole at A that leads to B, you would fall into the wormhole here and pop out there. And this would be in a different region of space and time. Okay. Right? So that's what a wormhole is. So it's kind of like a portal to one particular place, right? And it could be in a time in the past, I guess. No one's made a wormhole. There's nothing that says. I think on a microscopic level, right? One of the theories of quantum gravity, I think it says like there's all these tiny wormholes and all of this stuff. It's on a macroscopic level, and then there may be laws that prevent us from going in, maybe stop it from a macroscopic wormhole from being created, but also for us to go travel through it. So there might be all of these things. It's just that, honestly, because we don't have a full picture of gravity, that we just can't say definitively, no.
But in theory, now there's a few ifs in what I'm about to say, but if there was a wormhole and you could go through that wormhole, and let's say that pinged you in what you perceive as instantly 80 million light years away. So crazy distance. Now my next big if, so now you're sat, and let's say you're sat on a comfortable chair on a comfortable planet that happens to be wherever you've popped out of this wormhole. If you then had a telescope, like the super crazy telescope, and you zoomed in on planet Earth from where you are now, 80 million light years away, and you could zoom right in on planet Earth, and let's say you zoomed in right to where we're sat now. Now, you've instantly moved through that wormhole, and all you've done, I say all you've done, it's not an easy thing to do, but it's moved distance. So you've gone from one place to now you're 80 million light years away. Super telescope, look through the telescope at where we are now, what would you see?
Would you see that the Earth is more in the future than you are? Like for you?
Other way. So what you would see, so if you were looking, you've traveled 80 million light years, is that bit of light that left the Earth 80 million years ago. So you'd be looking at a planet covered in dinosaurs through your telescope.
Yeah, so you're looking into the past.
In what would be perceived to you as in that moment, looking through a telescope, you're now looking back into the past. So if find that wormhole, I think finding that telescope is going to be just as hard as finding that wormhole.
If you could make a wormhole, I think the telescope.
Well, you'd hope. So if you
I think you're going to telescope down.
So get the wormhole, get someone else to make the telescope, and you can look back into the past. And then hope you can come back. And when you came back, you'd be the Earth.
Well, it depends when you come back.
Yeah, but if you came back after 20 minutes, the Earth would have shifted.
Yeah, but it depends which region, which part of time you came. So with the wormhole, it could be not just in space, but also time.
Yeah.
So you could open up that wormhole at another region of time, another instant.
You might get lost in time, like Quantum Leap.
That's a TV show.
Yeah, but you got lost.
Yeah, okay.
He was always trying to find his way back to the right time.
Yeah, so, I mean, quantum gravity. Once we've got that down, we'd be able to know more. But we're constantly, figuring this out. So one of the things, a couple of years ago, they discovered gravitational waves, right? Which is predicted by Einstein in his theory 100 years ago. 100 years later, they actually detected it. Now, that opens up new possibilities, because if you can somehow create these gravitational waves, maybe you can create anti-gravity waves, and then now the only way you'd be able to time travel is by causing rip in space-time. So you have to affect space-time in a particular way and get it to fold or whatever it is to get it to do that, to time travel.
And there's other ways.
I know, it hurts your head. Just thinking about time, though, forget the time travel part, right? Because there are all these paradoxes in time travel as well.
We don't know the answer. We don't know how to do it. It's the bottom line.
But just thinking of time on its own, though, is just time isn't what it seems like it is. And that's the first thing that Einstein discovered, which is crazy that time moves at different rates.
So that mass, so we talk about space-time, and we understand something, the mass of the sun, and the gravity and the change that has the curvature of space-time. But if you got a super accurate clock, which we have, these atomic clocks that are crazy, crazy accurate. So if you're sat at the bottom of a mountain, that mountain has a huge amount of mass. Yeah. So for you at the bottom of that mountain, time will be moving slower than if I was stood in the middle of the desert. And we can use that. So it's a theory, we're not using it, but there's a super volcano in the US, which is an enormous, enormous volcano in Yellowstone Park. In fact, Yellowstone Park pretty much is a super volcano. Now, to predict when that was getting close to exploding, we know that there would be an increase of mass under the ground. Now, if you put an atomic clock in the middle of Yellowstone Park and another atomic clock somewhere not in the middle of Yellowstone Park and compared them, when there was a build-up of mass underneath that supervolcano, which predicts that, okay, it's getting closer and closer to blowing, this atomic clock would actually slow down. So you can use that theory to predict, in theory, you could do that to predict when a volcano was going to erupt by using time to take note of an increase in mass. So time is bonkers. It's not the same. Your time is different to my time.
How does that work? Because you have to compare it to something that doesn't. So you have to.
So you need two atomic clocks. It's like having one atomic clock on a plane.
Let's say you're on the phone, but even the light waves would be affected by the increased gravity. Mm-hmm.
What, bringing the clocks together or comparing the two?
Yeah.
There's got to be a way.
Yeah.
There's probably other ways of
time
doing it.
hurts my head. Okay, it really does. Yeah, so we can go into the future. There's no such thing as a present. We don't know about time travel in the past.
But you can see the past.
Yeah, you can see the past, right?
Yeah.
Any other questions?
No, I think.
I think we covered time travel. Did we?
We definitely
That would
spoke.
be amazing. I think I'd go in the past.
I'd
just to
go
see.
past. How far back though?
Just yesterday. I mean, there's some. I wish I would.
Something you really regret.
So you go in the future, like let's say a game, right?
Yeah.
Get the result, or just to like freak people out. Go like just slightly in the future and be like, "Watch this! I'm gonna make something drop or fall, or like,
Yeah.
or like if someone sneezes, right? You can say "bless you" before they sneeze, just to freak them out.
Right. So we give you the gift of time travel.
Just hijinks.
Like, oh, we'll have a laugh.
Yeah,
I'd go back.
I'm a simple man.
I'm sure I'd definitely go back. I'd be looking for the civilizations that maybe never
Yeah,
existed.
yeah, and then the Egyptians and stuff. Yeah, that'd be cool.
Yeah, no, go and have a look.
That would be cool.
You'd still go forwards?
I'm not sure. I don't really know.
Well, let us know. It's an important question. Just in case you ever solve it. I want to know where you're going.
I'd probably go back to like. I want to see dinosaurs. Like that'd be cool.
To be honest, I'd
That'd
be
be
very
cool.
tempted to come with you on that one.
There's a famous short story, right? About the butterfly. You step on one thing in the past. I can't remember. And then it changes everything. What's it called? I don't remember.
I know what you
I
mean.
read it when I was a kid.
So you got to go there and not affect anything in theory.
Yeah.
If you change something.
Or
then
you
it
just need
changes
one of
Yeah.
those time turner chains, right?
Yeah.
Yeah.
Well, it happened in Back to the Future.
yeah. Or
Change
you
the
can have a
past.
DeLorean
Yeah.
or a time. Is it time turner? Is
Yeah.
that what you call it?
Time trainer.
What's that from?
From Harry Potter.
Harry Potter.
Oh, God.
I should know
old
that.
person.
Oh my goodness. Sorry. I've read
Old
them.
man.
I love them.
I love them.
Yeah, I love them. Just forgot that detail.
Yeah. All right. Thank you for that awesome one question. I think that was.
Expansive question.
Yeah.
Mate. Expansive question.
All right. Thank you, Athena.
Do you enjoy that?
Yeah, it was really fun.
Awesome.
Cool.
Come on again.
Yeah.
Brilliant. High five.
Yeah, guys, and do your bit.
Thank you for watching. If we've got something wrong, you probably already have left a comment. So thank you for that. But if not, again, hit the. Are you a YouTuber? Is
No.
the
A
like-
lot of this
I
was
think-
speculative, by the way. So
Oh,
I
yeah.
don't, yeah, like this isn't.
the caveats.
I don't know for a fact about all
Nothing
of
we've
this.
said is fact.
I believe, yeah.
Yeah, sorry.
Anyway.
Sorry. I think the like button's down here, the subscribe button's down here, and the bell button, I think, is just down there, but please hit it. Let us know what you think. If you're listening on the podcast, give us a rate or press, I don't even know what it is that you
Yeah,
press.
just do something.
Press something. Do something. And if there's anything you'd like us in particular to discuss, again, just drop us a comment below. We'll have a look and maybe drag you in to ask the questions that they want to know.
Yeah.
Thank you very much for
Thank
watching.
you, Athena. Boop, boop.
Little wave.
Bye.
Thank you.